Good morning. My name is Elvina Yafta and I'll be explaining about three types of turbine. So what is turbine? Turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. So there are three types of turbine that I'll be explaining today, which are KAPLAN turbine, Francis turbine, and Pagoh turbine. So moving on to our first KAPLAN turbine. So KAPLAN turbine is a propeller type axial flow water turbine. It has adjustable blade which help in obtaining good efficiency at wide range of head and discharge available to the turbine. It is an evolution of Francis turbine. It is designed to operate where head is low, unlike Francis turbine. So this is the basic circuit. So as we know, KAPLAN turbines are capable of working at a very low pressure and high flow level compared to other hydro turbine types, which are Francis and Pagoh. Its performance of service can exceed 90%. KAPLAN turbines are generators for reaction. These work on the aspiration and pressure sides of turbines with a complete body of water, while impulse turbine run without pressure. The operating condition of a KAPLAN turbine can be tightly regulated in combination with a variable wicket gap to optimize output. So moving on to the principle of operation and characteristic. The water from the stop is created to reach the scroll jar. The scroll case is designed in the shape appropriate to prevent the loss of the flow pressure. The guide draws the water towards the runner blades. The valves can be adjusted and tailored to the flow rate requirements. The water turns at about 90 degrees so that the stream axial resembles that of runner blades. When the water hits the reaction force of the water, the rudder blades begin to rotate. In order to achieve a better efficiency, the runner blade twists along their length to achieve an optimal angle of attack over the blades. The water enters the drainage pipe from the runner blades and reduces their energy pressure and kinetic energy. Kinetic energy is converted into pressure energy and raises water pressure. The turbine rotation is used in the creation of electricity by turning the generator shaft. So moving on to the application. So there are four applications of KAPLAN turbine. KAPLAN turbines are commonly used in power generation worldwide. So second, it can work more efficiently at low water head and high flow rates as compared with other types of turbine. Second, it is smaller in size and easy to construct. And lastly, the efficiency of KAPLAN turbine is very high as compared with other hydraulic turbine. Okay, as for the advantages and disadvantages of KAPLAN turbine, for the advantages, it can be used for the sites having very low head. The number of blades is less. Next, at parts loads, there is reduced loss of efficiency. The fourth point is KAPLAN turbines has efficiency up to 90%. And lastly, it required less space and it has adjustable runner vents. As for the disadvantages, cavitation is a problem which occurs due to the pressure drop in the draft tube. Second, high flow rate is required to use KAPLAN turbine. And lastly, they are very expensive to design, manufacture and install. That's all for KAPLAN turbine, and I'll be explaining about Francis turbine next. Okay, for Francis turbine. So what is Francis turbine? Francis turbine is a type of water turbine. It is the most common water turbine in use today. They operate in waterhead and are used primarily for electrical power production. So this is the basic circuit for Francis turbine. The turbine cutting edges of Franco are designed so that a portion of its edge configuration allows the weight difference between the opposite essences of the sharp edge when it is pushed by water, and the other edge configuration of the segment use the water drive force which hits it. Thus, the movement and future energy of the water at the time of leisure will be decreased, as it is at this point when the turbine enters. The turbine is supplied with high pressure water for the power generation. Use the Francis turbine, which penetrates the radial inflow turbines and lifts the turbine axial through the tubing. Through torque and rotation, the water flow energy is transmitted to the turbine shaft. The turbine shaft is attached to the dynamos or power generation alternators. Notwithstanding the changing loads, the turbine will maintain constant speed for high quality power generation. The water flow rate is decreased by adjusting the angle of the guiding vanes to keep the runner speed constant even in decreased load condition. Okay, now for the principle of operating and characteristic. Water reaches the turbine by winding packing and reaches the sharp edges of the sprinter and passes through the vanes and guide vanes. As the winding packing area declines along the packing length and maintain a homogeneous weight of energy, while a little of water enters the edges of the sprinter and wherever the sprinter will cut. The stay vanes are stationary and expels the thrills from the water, which are naturally created by tilting, and tries to slowly make the water stream directly avoidable by custom guide gaps. This ensures the turbine yields on the edges of the guidance valves. The approach of the water to the sprinter edges. Guide vanes also test the water stream in the sharp sprinter tops and thus interact with the hip on the turbine. The edges of the sprinters are steady and cannot slope or change angle, so the guide valve control the turbine's performance. Furthermore, the upper part of sprinter's sharp edges is designed to use the mass contrast of a water passing cutting point, much as an airfoil uses the weight difference to create lift constraints. Moreover, the remainder of the part of the sharp rim is designed as a ball, allowing use of the dynamic vitality of the water. The sprinter cutting's edges therefore allows the most powerful use of both the vitality of weight and dynamic vitality of the water and turn the sprinter. We use the drainage cylinder to recuperate the weight as it moves forward tail racing, but at the same time we are unable to recover the weight to such an extent that we can allow air to reach the sprinter lodging, which results in cavitation. Okay, as for the applications of Francis turbine, first, Francis turbine is the most widely used turbine in hydropower plants to generate electricity. Second, mixed flow turbine is also used in irrigation water pumping sets to pump water from ground for irrigation. Third, it is efficient over a wide range of water, head, and flow rate. Fourth, it is most efficient hydro turbine we have till today. And lastly, franchise turbine may be designed for a wide range heads and flows. This, along with their high efficiency, and has made them the most widely used turbine in the world. Next is the advantages and disadvantages of franchise turbine. So for the advantages, first, no head failure occurs still at the low discharge of water. Second, franchise turbine variation in the operating head can be more simply controlled. Third, the runner size is small. And lastly, changing the head is easily controlled. And for the disadvantages, first, the water which is not dirt-free can cause extremely rapid wear in a high-head franchise turbine. Second, the repair and inspection are much harder reasonably. Third, cavitation is an ever-present hazard. And lastly, the current losses are certain. Okay, that's all for franchise turbine, and I'll be continuing to Pelton turbine. Okay, this is our last type of turbine, which is Pelton turbine. So what is Pelton turbine? Pelton turbine, or wheel from Pelton, is a type of turbine commonly used in hydropower plants. Usually, these turbines are used for sites with head over 300 meters. When it is used for power generator, a water reservoir is normally placed above Pelton turbine at a certain height. Okay, as for basic circuit for Pelton turbine, it has many calculations compared to the two basic circuit, which are KAPLAN and franchise turbine. So I'll be explaining about a theory of the basic circuit. So first is the energy and initial jet velocity. In ideal case, which is frictionless, all the hydraulic potential energy is converted into kinetic energy, and you can refer this through Bernoulli's principle. Next is final jet velocity. Assuming that the jet velocity is higher than the runner velocity, if the water not becoming backup runner, then due to conservation of mass, the mass entering the runner must equal to the mass leaving the runner. Okay, the third one is optimal wheel speed. We know that the ideal runner speed will cause all of the kinetic energy in the jet to be transferred to the wheel. In this case, the final jet velocity must be zero. Okay, next, the fourth point is torque. By referring Newton's second and third law, the force imposed by the jet on the runner is equal but opposite to the rate of momentum change of the fluid. The torque maximal when the runner stops. The next point is about power. This quantity exactly equals the kinetic power of the jet. So in this ideal case, the efficiency is 100%, since all the energy in the jet is converted to shaft output. So lastly is about efficiency. When a real Pelton wheel is working close to the maximum efficiency, the fluid flows off the wheel with very little residual velocity. In theory, the energy efficiency varies only with the efficiency of the nozzle and wheel and does not vary with hydraulic head. As for principle of operation and characteristic, it is very easy to run a Pelton turbine. High-speed water jets emerge in this form of turbine from the turbine nozzles. Such nozzles are arranged in such a way that the water jet enters the puddles at splitters in the middle of the pond. Then the two separate streams flow through the bucket's internal curve and exit in the opposite direction. This change in water dynamics gives the blades of the turbine an impulsion and generates torque and turbine rotation. The high-speed water jets are caused by the acceleration of high-pressure water by the air pressure particle. The optimum output of Pelton turbine is achieved when the pulse produced by the blades are optimum, so that the water stream is deflected precisely in the opposite direction. Even when the speed of the cup movement is half that of the water jet, the performance of these wheels is the best. Now moving on to the application of Pelton turbine. The Pelton turbine and the cross-flow turbine in particular are suited to local production for the range of turbine power output mentioned in this paper. The application range is lower head and higher flow levels of the cross-flow turbine. The Pelton turbine has a lower output. Moreover, centrifugal pumps that works in the reverse direction are also possible during turbine operation. The next application is Pelton turbines are also suited for semi-permanent application. The third point is, due to its pollution-free operation, the Pelton turbines can be installed in drinking water supply scheme. And lastly, the attachment of a water pump to the turbine is another function of the direct drive. This is a quick and simple way to pump the water up at a position above the intake. Thus, the head can be used at the turbine intake and only the height difference between intake and consumption and losses in friction must be met. So, lastly is advantages and disadvantages. As for advantages, first, the Pelton turbine is the most efficient of hydro turbines. The next point is, it operates with a very flat efficiency curve. The third point is, it operates on the high head and low discharge. And lastly, it has a tangential flow, which means that it can have either axial flow or radial flow. As for the disadvantages, first is the efficiency decreases very quick with time. Second, the turbine size runner, generator and powerhouse required is large. And lastly, the variation in the operating head is difficult to control because of high heads. So that's all from me and my explanation about the three types of turbine. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Muhammad Ashraf bin Nasruddin. My metric number is AA180525. Today I want to present about inverse time relay and directional relay in protection system. Firstly, we briefly about inverse time relay and directional relay in protection system. In electrical engineering, a protective relay is a relay device designed to trip a circuit breaker when a fault is detected. The first protective relays were electromagnetic devices, relying on coils operating on moving parts to provide detection of abnormal operating conditions such as overcurrent, overvoltage, reverse power flow, overfrequency, and underfrequency. The theory and application of this protective device is an important part of the education of a power engineer who specializes in power system protection. The need to act quickly to protect circuit and equipment often requires a protective relay to respond to a trip breaker within a few thousandths of a second. In instances, these clearance times are prescribed in legislation or operating rules. A maintenance or testing program is used to determine the performance and availability of protection system. In inverse time relay, A relay that operates or pickups when its current exceeds a predetermined value setting value is called overcurrent relay. For feeder protection, there would be more than overcurrent relay to protect different sections of a feeder. These overcurrent relays need to coordinate with each other such that the relay nearest fault operates first. Use times, currents, and combination of both time and current are three ways to discriminate adjacent overcurrent relays. Overcurrent relay ratings. In order for an overcurrent protective device to operate properly, overcurrent protective device rating must be properly selected. This rating includes voltage, ampere, and interrupting rating. Current limiting can be considered as another overcurrent protective device rating, although not all overcurrent protective devices are required to have this characteristic. Voltage rating. The voltage rating of the overcurrent protective device must be at least equal to or greater than the circuit voltage. The overcurrent protective device rating can be higher than the system voltage but never lower. Ampere rating. The ampere rating of overcurrent protecting device normally should not exceed the current carrying capacity of the conductors. As a general rule, the ampere rating of an overcurrent protecting device is selected at 1 to 5% of continuous load current. Directional overcurrent relay. This is also a special type of overcurrent relay with directional features. The directional overcurrent relay employs the principle of actuation of the relay when the fault current flows into the relay in particular direction. If the power flow is opposite direction, the relay will not operate. Normally, the conventional overcurrent relay non-direction will act for fault current in any direction. Directional overcurrent relay recognizes the direction in which fault occur relative to the location of the relay. The principle of the directional protection is as under. Consider feeder XY is passing through station A. The circuit breaker in feeder AY is provided with the directional relay R, which will trip the breaker CBY. If the fault power flows in direction AY alone, therefore for fault in feeder AX, the circuit breaker CBY does not trip unnecessarily. However, for fault in feeder AY, the circuit breaker CBY trips due to the direction feature of the relay set to act in direction AY. This type of relay is called reverse directional overcurrent relay. This is also a special type of overcurrent relay with directional features. This directional overcurrent relay employs the principle of actuation of the relay. When the fault current flows into relay in a particular direction, if the power flow is the opposite direction, the relay will not operate. Normally, the conventional overcurrent relay non-directional will act a fault current in any direction. The directional overcurrent relay recognizes the direction in which the fault occurs relative to the location of the relay. The principle of the directional protective is as under. Consider a feeder XY passing through station A. The circuit breaker in feeder AY is provided with a directional relay R, which will trip the breaker CBY if the fault power flow is in direction AY alone. Therefore, for faults in a feeder XY AX, the circuit breaker CBY does not trip unnecessarily. However, for fault in feeder AY, the circuit breaker CBY trips due to direction feature of the relays set to act in the direction AY. This type of relay is also called reverse power relay. So far as direction of current power flow is concerned, reverse power flow relays with directional feature not only sense the direction flow but also measure magnitude of power flow. Directional relay, whenever a near or close-up for occur, the voltage becomes low and directional relay may not develop sufficient torque for its operation. To get sufficient torque during all types of faults, irrespective of location with respect to relay, the relays connection are to be modified. Each relay is energized by current from its respective phase and voltage. One of the method such connections in 30-degree connection, or others is 90-degree connection. Second, basic construction. Basic construction of inverse time relay. This operates in a time that is inversely proportional to the fault current that shown in figure 5.8. The advantage over definite time relay is for very high currents, much shorter tripping times can be obtained without risk to the protection selectively. Inverse time relay are also referred to as inverse definite minimum time, or IDMT, over current relays. This is an example of characteristic of inverse time relay. Directional relay. Directional relay, it is used when it is necessary to protect the system against fault current that could circulate in both directions through a system element, and when bidirectional overcurrent protection could produce unnecessary disconnection of circuits. This can happen in ring or mesh type system and in a system with a number of in-fade points. Directional relay are constructed using normal overcurrent unit plus a unit that can determine the direction of the power flow in associated distribution system element. This second unit requires a reference signal to measure the angle of the fault and thus determine whether or not the relay should operate. The diagram of the proportional relay as a transmission line is shown in figure 5.9. This is basic circuit for directional relay. Basic circuit and associated related circuit inverse time relay. Here in the graph, it is clear that when activating quantity is OA, the operating time of the relay is OA. When activating quantity is OB, the relay operating time is OB. And when activating quantity time is OC, the operating quantity is OC. In the graph above, it will also observe that when activating quantity is less than OA, the relay operating times become more infinity, which means the activating quantity less than OA, the relay does not at all activate. This minimum value of activating quantity for which a relay initiates its operation is known as pickup value of activating quantity. Here it denoted as OA. It is also seen from the graph that activating quantity approaches to infinity along x-axis. The operating times does not approach to zero. The curve approaches to an approach to an approximately constant operating time. This is approximately minimum time required to operate the relay. Directional relay. Construction details figure 0.21.1819 show the essential parts of the typical induction type directional power relay. It consists of an aluminium disc which is free to rotate in between the poles of two electromagnets. The upper electromagnet carries a winding called potential coil on the central limb, which is connected through a potential transformer to the circuit voltage source. The lower electromagnet has a spread winding called current coil connected to the secondary of CT in the line to be protected. The current coil is provided with a number of trapping connected to the plug setting match, not shown in clarity. This permits to have any desired current setting. The restraining torque is provided by a spiral spring. The spindle of disc carries for moving contact which bridge two fixed contact when the disc has rotated through preset angle. By adjusting the angle, the travel of the moving disc can be adjusted and any desired time setting can be given to the delay. Thirdly is principle of operation and characteristic. Principle of operation characteristic. The relay operates only when the magnitude of their operating current is inversely proportional to the magnitude of the energized quantities. The operating time of relay decreases with the increase in the current. The operation of the relay depends on the magnitude of the current. The characteristic curve for the relay is shown in figure below. The relay will not operate when the value of current is less than the peak value. The relay is used for protection of the distribution lines. The inverse time relay has three types. First, inverse definite maximum time relay. The relay whose operating time is approximately proportional to the fault current is known as IDMT relay. The operating time of the relay is maintained by adjusting the time delay setting. The IDMT relay uses the electromagnetic core because it can easily saturate for the current having larger magnitude than pickup current. The relay is used for the protection of the distribution line. Second, very inverse line relay. The very inverse characteristic of the relay is more than IDMT. Such type of relay is used in the feeder and on long transmission lines. The relay is used in the place where the magnitude of the short circuit current fall rapidly because of the larger distance from the source. It is used for sensing the fault current which is free from the fault location. That is extreme reverse relay. Extreme reverse relay is the characteristic time of the relay is extremely large as compared to IDMT and the very reverse relay. This relay is used for protecting the cable, transformer, and other. The relay can operate instantly when the pickup value of the current is more than the relay setting time. The relay provides faster operation even under the fault current. It is used for sensing the overheating of the machines. The inverse time relay is used in the distribution network and the power plants. The relay gives the fast operation in a fault condition because of their fault time characteristic. Operation, the flux due to the current potential coil will be nearly 90 degree lagging behind the applied voltage. The flux due to current coil will be nearly in phase with the operating current. See vector diagram in figure 1.18. The interaction of flux 1 and flux 2 with the eddy currents induced in the disc produce the driving torque by given by induction type directional power relay. Induction type directional power relay, it is clear that the direction of driving torque on the disc depends on the direction of power flow in the circuit to which the relay is associated. When the power in the circuit flows in the normal direction, the driving torque and the restraining torque due to the spring help each other to turn away the moving contact from the fixed contact. Consequently, the relay remains inoperative. However, the reversal of current in the circuit reverses the direction of driving torque on the disc. When the reverse driving torque is large enough, the disc rotates in the reverse direction and the moving contact crosses the trip circuit. This is because the operation of the circuit breaker which disconnect the faulty section. Fault is application. Motor protection. First is motor protection. Use against overload and short circuit in stator windings of motor inverse time, and instantaneous overcurrent phase and ground. Overcurrent relay used for motor above 1 kilowatt, 1000 kilowatt. Transformer protection. Second is transformer protection. Used only when the cost of overcurrent relays are not justified. Extensively also at a power transformer location for external fault backup protection. Third is line protection. On some transmission lines where the cost of distant relaying cannot be justified. Primary ground fault protection on the transmission line where distant relays are used for the phase faults. For ground backup protection on most lines having parallel relaying for primary protection. Fourth is distribution protection. Directional relay to have power or current flow in the correct direction could be very important at times, such as when you have a diesel generator operating, you do not want power to flow back into the DG for any reason. So you would normally put a device TT2R reverse power relay in the DG setup so as to protect against power going in the reverse direction. In transmission field, the power flow and direction take on even more importance and usually need to be custom designed to provide protection correctly. 5 in this is advantage of inverse time relay and directional relay. Advantage of inverse time relay are the use of extremely inverse overcurrent relays make it possible to use a short times delay in spite of high switching in current and likely suitable for the protection of machine against overheating. Hence effective with ground fault because of their step characteristics. Moreover, the use of extremely inverse overcurrent relay makes it possible to use a short time delay in spite of high switching in currents. Directional relay. Advantage of directional relays: electromagnetic relays have fast operation and fast receipt. They can be used for both AC and DC system for protection of AC and DC equipment. They have the properties such as simple, robust, compact, and reliable, and these relays are almost instantaneous. Disadvantage of inverse time relay are the continuity in the supply cannot be maintained and the load and in the event of fault. Plus, it is not suitable for long distance transmission lines where rapid fault clearance is necessary for stability. Moreover, relay have a difficulty in distinguishing between fault currents at one point or another when fault impedance between these points are small. Thus, for discrimination, and last, it is difficult to coordinate and requires change with the addition of load. The disadvantage of directional relay is the directional relay feature is absent in electromagnetic relays. Require periodic maintenance and testing unlike static relays. Relay operation can be affected due to aging of the component and thus pollution resulting in spurious trips. Thank you. That's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azra Winter Abdul Halim and my number matrix is AA181891. So today I will present about my part in this group assignment, which is three-phase transformer connection. We move on to the introduction of three-phase transformer connection. Windings of three-phase transformer can be connected in various configurations such as star-star connection, delta-delta connection, star-delta or delta-star connection, and the associated circuit are open delta and Scott connection. So okay, we move on to the basic construction. The three-line core type three-phase transformer is the most common method of three-phase transformer construction, allowing the phases to be magnetically linked. Flux of each limb uses the other two limbs before it returns path with the 3 magnetic flux in the core generated by the line voltage, differing in time phase by 120 degrees. Thus, the flux in the core remains nearly sinusoidal, producing a sinusoidal secondary supply voltage. The shell type 5-limb 3-phase transformer construction is heavier and more expensive to build than the core type. 5-limb cores are generally used for very large power transformers as they can be made with reduced height. A shell type transformer core material, electrical winding, steel enclosure, and cooling are much the same as the larger single-phase type. So we move on to the next point, which is basic circuit and its related circuit. The first circuit I will explain is star-delta connection. But what do we mean by star and delta? Which star is also known as Y and delta is also known as mesh. When dealing with 3-phase transformer connection, a 3-phase transformer has 3 sets of primary and secondary windings. Depending upon how the sets of windings are interconnected, determines whether the connection is star or delta configuration. The standard method for marking 3-phase transformer winding is to label the 3 primary windings with capital uppercase letter. For example, A, B, and C, used to represent the 3 individual phases of red, yellow, and blue. The secondary windings are labeled with small lowercase letter with A, B, and C, representing each color, red, blue, and yellow. Each winding has 2 ends, normally labeled with 1 and 2. For example, the second winding of primary has end which will be labeled as B1 and B2, while labeled as C1 and C2 for the third winding. So we move on to the next connection, which is delta-delta connection. In delta-delta connected group of transformer, the line voltage VL is equal to the supply voltage, which means VL equal to Vs. But the current in each phase winding is given as 1/3 times IL of the line current, where IL is the line current. One disadvantage of delta connected 3-phase transformer is that each transformer must be wound for the full line voltage. In our example here is 100 voltage for 57.7% line current. The greater the number of turns in the winding together with the insulation between turns necessitate a larger and more expensive coil than the star connection. Another disadvantage with delta connected 3-phase transformer is that there is no neutral or common connection. So we move on to the next connection, which is star-star connection. In star-star arrangement or YY, each transformer has one terminal connected to a common junction or neutral point, with the 3 remaining ends of primary winding connected to the 3-phase main supply. The number of turns in a transformer winding for star connection is 57.7% of that required for delta connection. The star connection requires the use of 3 transformers and any one transformer become fault or disabled. The whole group might become disabled. Nevertheless, the star connected 3-phase transformer is especially convenient and economical in electrical power distributing system. In that fault, wire may be connected as neutral point of the 3 star connected as secondary as shown. So this is the associated circuit, open delta, as you can see here, and then the Scott connection. This is the connection. So, okay, we move on to the principal operation and characteristic. As you can see in the slide given to you, the table here, it says that we know that there are 4 different ways in which 3 single-phase transformers may be connected together between their primary and their 3-phase circuits. These 4 standard configurations are given as delta delta, star star, star delta, and delta star. So this is the star delta turns ratio, and then this is the star delta star turns ratio. So this is the table for 3-phase transformer line voltage current, and you can see the formula here given. So the application for star 3-phase connected transformer, you can see from the given picture, it shows that VL is line to line voltage and VP is the phase to neutral voltage, and this is the table for the formula. So next we move on to the advantages and disadvantages of 3-phase transformer connection. The advantages is are less cost, less weight, less size, less time required to assembly, require less space, deliver more power, higher efficiency, easier to install, easy transportation and installation, easy to repair and easy assembling. The disadvantages are greater cost of standby unit, increased cost and inconvenience of repair, and in single-phase transformer, 3 single-phase transformer, failure of one transformer, the other 2 single-phase transformers still supply the power, but it is not possible in case of failing the 3-phase transformer. I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfatia binti Harun and my metric number is AA181839. Today I would like to tell you about my research on transmission line. First of all, I would like to tell you about what is a transmission line. Transmission line is like a strip line and a microstrip. When the frequency of electromagnetic wave moving through a given cable or medium is higher, it will make the waveline of the wave become shorter. And basically, transmission line used for the transmission of electrical power from generating substation to the various distribution unit. It transmits the wave of voltage and current from one end to another. Transmission line is made up of a conductor having a uniform cross-section along the line. Next, I would like to tell you about the basic construction of a transmission line. The basic construction of transmission line involves 4 activities. It was a site preparation, a foundation construction, a structure construction, and lastly a wire stringing operation. Now, I would like to tell you about the basic circuit for the transmission line. This is the basic circuit for the transmission line. The performance of transmission line depends on the parameter of the line. The transmission line has mainly 4 parameters: resistance, inductance, capacitance, and shunt conductance. These parameters are uniformly distributed along the line. Hence, it is also called the distributed parameter of the transmission line. Next, I would like to tell you about the principle of operation and the characteristic of transmission line. Okay, transmission line is a pair of parallel conductors exhibiting Cartesian characteristics due to distribute capacitance and inductance along its length. When a voltage is suddenly applied to one end of the transmission line, both a voltage wave and a current wave propagate along the line at nearly light speed. Now I would like to tell you about the application of a transmission line. Actually, transmission line already had been widely used in our daily life. For example, transmission line already had been applied in our communication gadgets such as telephone, cable TV, and broadband network. Besides that, it also already had been applied in high-frequency circuit and a microwave application such as radar system and a GPS. Just like everything in this world, transmission line also have its own advantages and disadvantages. The advantages of transmission line is it has a high power transmission, low installation and material costs, long distance transmission, the damage in overhead line can easily locate, the maintenance of the line is easier. And the disadvantages of transmission line is because the installation and maintenance cost of underground transmission is high. It also has a high complication in fault detection and maintenance. And the high voltage transmission is difficult in underground transmission. And lastly, transmission line is limited by thermal capacity. That's all from me. Thank you.
Hi, my name is Nur Ansadna binti Ismail. Today I will explain about earthing system. That is, have three types of earthing system: IT, TT, and AM system. Earthing system is an electrical installation, and earthing system UK or grounding system US connect specific parts of the installation with the Earth's conductive surface for safety and functional purpose. The point of reference is the Earth's conductive surface. Okay, the types of system earthing has three. That is the main distributed system are TN system, PT system, and IT system. The first letter is relationship of distribution system to Earth, and the second letter is relationship of the exposed conductive part of the installation to Earth. Okay, for the IT system is the IT distribution system has all life parts isolated from Earth or one point connected to Earth through an impedance, the exposed conductive part of the electrical installation beneath Earth. Okay, that is three: independently or collectively or to the earthing of the system. Okay, IT system is the star of the supplying transformer is connected to Earth through the installation connected to the protective Earth PE of the system. In TT system, there is active part insulated from Earth or connected to Earth through a high impedance. The high impedance can apply for metrological reason, provided electrical safety. Okay, for the this is the IT system construction. Okay, for the basic construction, the unearthed IT system has transformer that independent power source such as battery. This is battery or generator are used since no active conductor is connected to Earth with low resistance, the current will flow through the circuit lah. Okay, for the basic circuit, the IT system is no international connection between the neutral point of the supply source and Earth. Okay, there are no connection at the Earth. For the principle, the protection technique is interconnection and earthing of exposed conductive part, indication of the first fault by an insulation monitoring device IMD, and interruption for the second fault using overcurrent protection. For the operation technique, we will monitoring of the first insulation fault, mandatory location and clearing of the fault, interaction for two simultaneous insulation fault. Okay, this is figure 5. You can see the current will go through the connection and go to the transformer. The main characteristic is solution offering the best continuity of service during operation. It requires a high level of insulation in the network. So to check the effective of the tripping of two simultaneous, fault must be carried out by calculation during the design stage, followed by a mandatory measurement during the commissioning on each group. So the protection of the neutral conductor must be ensured as indicated in protection of the neutral. Okay, for the application is this IT system using in hospital and marine. Some industry application use IT for ensure that faulty current does not represent, and in photovoltaic application. Okay, the advantage is fault location during operation, no shutdown, increased protection of person, less test cost, and increased fire protection. For the disadvantage, each customer need to install it on ground electrode. High over voltage may occur between all live part and between live part, and it possible over voltage stress on equipment insulation of the installation. For the TN system, the TN system is the supply source transformer neutral is directly connected to earth and all exposed conductive part of an installation connected. The transformer neutral is earthed, so the frame of the electrical load connected to the neutral like this. Neutral will be connected to the load, and the fault voltage referred now as indirect contact. The impedance of the outgoing circuit is equal to that written one. Okay, for the basic construction, it has three types of TN earthing system, that is TNC, TNS earthing system, and TNCS earthing system. So for the TNC earthing system, the neutral and protective function combined in single conductor, and the supply source is directly connected to earth and all exposed conductive part of an installation are connected. Okay, for the TNS earthing system, the TNS system separate neutral and protective conductor throughout the system, so it will not connect each other. The main earthing terminal of the installation. Okay, for the TNCS earthing system, the neutral and protective function combined in a single, so neutral and PE connection will connect each other, and TNS downstream for the TNC. All exposed conductive part of an installation are connected to the fan conductor via main earthing terminal. So the pH and wire will not connected. It is the TNCS earthing system. Okay, for the basic circuit is for the TNS, PE and neutral is separate like this. All the wire will not connect each other. The consumer will split, and for the TNC, the PE and N conductor will combine each other lah. For the TNCS, the separate PE and N conductor is fixed indoor wiring and flexible power cords. Okay, for the principle, in the system, ID must be higher or equal to IA. It has this is the disconnection by circuit breaker for a return system. The UO for the first is greater than second, so it will go up and combine. For the characteristic, the technique for the protection is interconnection and earthing of exposed conductive part, and the neutral are mandatory. For the operating technique, the interaction for the first isolation fault, the TNC system like this, the wire, this is for TNS system. And for the main characteristic is require the installation of earth electrodes at regular intervals throughout the installation. And for the TNC, the first plan will appear to be less expensive from other, and the TNS may be used when with flexible conductor and small conduits. Okay, for the application, the typical application is industrial utilities for building installation, and medium or high and medium high TNS, value of short S, value of short circuit current to circuit current to earth, and protection against earth, protection against earth fault, over current protective device or ground residual current. Okay, advantage, the TN earthing system always provide a return parts of fault in the LV grade, lower earthing resistance of the PN conductor, and also no over voltage stress on equipment insulation. For the disadvantage, fault in the electrical network at a higher voltage level may migrate into the LV grade grounding, causing touch voltage LV customer, and the utility is not only responsible for a proper grounding but also for the safety customer during disturbances in the power grid. Okay, for the protection to be fitted in case of network modification. Okay, lastly is TT system. It is a basic construction. In the TT earthing system, the protective earthing connection for the consumer is provided by a local earth electrode. Sometimes it referred to as the terra firma connection. This is the basic construction. It has L1, L2, L3 and neutral. It will connect, consumer will connect with N, but it's separate lah, not connected each other. The big advantage of the TT earthing system is the reduced conductor interference from other user connected equipment. Okay, for the basic circuit, the TT system uses an earthed neutral at the supply transformer and earth electrode at the user's installation. Okay, this is the TT system. The IE requirement figure for external load impedance for a TT system is up to 2000. All the current 200 ohm, all the current standard define a higher maximum value, ZE equal to 2000 volt equal to 230 volt lah. BFC, okay. For difficult to make connection, method for testing an RCD, figure 4, B is greater than A. Okay, for the principle, I is the current is the rated residual operation current of the RCD is less than and equal to 50 over RA. This is the example. The resistance of the earth electrode of substation neutral Rn is 10 ohm. Okay, if the current is 3 ampere, the maximum resistance for the 50 volt is 16 ohm, and for the 25 volt is 8 ohm, and for 30 milliampere, the maximum is 1666 ohm for 50 volt and 833 ohm for 25 volt. The characteristic is technique for the protection of person. The exposed conductive part, earth and residual current device RCDs are used. For the operating technique, the interaction for the first installation fault is the circuit for DT system. Okay, the main characteristic is simplest solution to design and install, does not require continuous monitoring during operation. Protection is ensured by special device. Okay, for the application, for the typical application, it for domestic and small industrial installation fed by the utilities direct from the low utilities direct from the low voltage network small values of short, circuit current to earth typically 10 to 100 ampere. Protection against to earth fault, residual current protective device, residual current protective device over current protective device. For the advantage is the most commonly found earthing system fault in the LV and MV grid do not migrate to other customer in the LV grid. Simple earthing of the installation and the easiest to implement. Okay, for this advantage, each customer needs to install and maintain its own ground electrode. High over voltage may occur between all live parts and between live part and PE conductor. And lastly, is possible over voltage stress on equipment installation of the installation. Okay, that's all from me for the earthing system. Okay, thank you.